Welcome to Saashiv Cleantech Academy. Together, we can build a smarter and more sustainable energy future. Welcome to this detailed walkthrough of the Factory Acceptance Test, or FAT, for a containerized battery energy storage system. This test was conducted at the BMS vendor's facility and is a critical milestone in ensuring system readiness before deployment. Presented by Saashiv Cleantech Academy, this session will guide you through the procedures, tools, safety protocols, and performance benchmarks that define a successful FAT. The FAT is designed to validate the functionality, safety, and integration of all major components in the BESS system. Conducted at the BMS vendor factory over approximately 5 days, the test covers everything from battery racks and BMS hardware to control interfaces and communication protocols. It's not just a checklist, it's a confidence-building exercise for both vendor and client. Let's look at the core components under evaluation. First, the battery rack, specifically the NESP series model 51.2 NESP 160, is inspected for structural integrity and electrical performance. The battery management system, or BMS, is tested for its ability to monitor, protect, and communicate. We also assess the control box, BAU, and HMI for responsiveness and data accuracy. Each element plays a vital role in system stability and safety. To ensure precision, we use a range of calibrated tools. Laptops are essential for diagnostics and data logging. Multimeters help verify voltage and current readings. Torque spanners ensure mechanical connections are secure. The clamp flow meter measures current flow without direct contact, ideal for high-voltage environments. Every tool is selected for reliability and safety. Safety is non-negotiable. Access to the test zone is restricted to trained personnel. Everyone must wear PPE, helmets, gloves, insulated tools, and long-sleeved clothing. Loose garments and jewelry are strictly prohibited. Fire hazards, chemical exposure, and electrical risks are mitigated through strict adherence to H&SE protocols. This ensures a safe environment for both technicians and observers. The rack frame is visually inspected for scratches, corrosion, and deformation. We check that the logo is clean and properly printed, with no smudges or missing labels. Screw alignment and hole positioning are verified to ensure mechanical stability. Even the door handle is tested for ease of access, because every detail matters in long-term operation. Battery modules undergo a thorough inspection. We verify that the appearance is clean, labels are legible, and there's no physical damage. Voltage readings must meet or exceed 51.2 V. Terminal polarity is checked to prevent reverse connections. The installation interface is assessed for alignment and secure mounting. These checks ensure safe and efficient energy storage. Performance testing simulates real-world load conditions. The system is charged and discharged at 80A and 212.99 kilowatts. Cell voltage must remain between 2.5 V and 3.8 V, and rack voltage between 582.4 V and 748.8 V. We monitor temperature, voltage imbalance, and efficiency, targeting a minimum of 93%. This phase confirms that the system can handle operational stress without compromising safety. The BMS hardware is inspected for build quality and wiring integrity. The control box must be free of corrosion and physical damage. BAU and HMI interfaces are tested for responsiveness and data accuracy. Communication ports, including CAN, UART, and Ethernet, are verified for reliable data exchange. The display screen is checked for brightness, clarity, and correct labeling. Functional testing ensures the BMS can monitor voltage, current, and temperature across all battery strings. Protection functions are triggered when thresholds are breached, such as overvoltage or undervoltage. Communication with BMU, BAU, and HMI must be seamless. Parameters are configured via the HMI, and alarm logs are reviewed to confirm system responsiveness. This ensures the BMS is not just functional, but intelligent. Once all tests are completed and any discrepancies resolved, the system is formally accepted by the client. This includes signed documentation and test records. Acceptance confirms that the BESS is ready for dispatch and installation. It's a moment of assurance for the vendor, the client, and the future performance of the system. To summarize, the FAT validates the mechanical, electrical, and functional integrity of the BESS system. It ensures safe, reliable operation and builds trust between stakeholders. The next steps include site installation, commissioning, and continuous monitoring. At Saashiv Cleantech Academy, we believe FAT is not just a procedure, it's a promise of quality and performance. Thank you for learning with Saashiv Cleantech Academy. Together, we can build a smarter and more sustainable energy future.